It is called the first overtone. Now students, we will discuss about the third harmonic for third harmonic and this third harmonic is also called the second overtone. To show the third harmonic in the stationary waves in a closed pipe, observe here, we have started from this node, and it was the first position where we heard the loud sound, the first loud sound, and it was a position where we heard the second loud sound. So it means at the third antinode position we will heard the third loud sound. Now our objective is to find the frequency of the waves generated in the air to heard the third loud sound. So it means we will show here in this diagram the two complete loops and one half loop. Now we can represent the positions of node and antinode. Now we have 3 nodes and 3 antinodes in this diagram, and we will heard the third loud sound, and we can show here the length of the tube is now converted in how many wavelengths. So to find out the number of wavelengths, we will take help from this diagram. If we start from here, that is the first node which is formed at the closed end, and this antinode is formed at the open end. So it means the one cycle is complete, that's why one wavelength, and it is a quarter wavelength for the half of the loop. So we can calculate here the one wavelength plus the quarter wavelength, that is equals to the 5 lambda over 4. So it means for 2 complete loops and 1 half loop, the wavelength becomes now the 5 lambda over 4. So this complete length of the tube is converted into the 5 lambda over 4 wavelength. That is L is equals to 5 lambda over 4, and the lambda becomes now the 4 times of the length of the tube divided by 5. And we will use the wave equation to calculate the frequency, that is V is equals to F lambda, and we know that the F is equals to V over lambda, and we can substitute the value of the lambda in terms of the length of the tube, that is 4L over 5. Now we'll shift this 5 in the numerator, so it can be written as the 5 times of the V over 4L, and this V over 4L can be written in the form of the fundamental frequency. Now because of the third harmonic, we can show here the 3, and we can show this frequency in terms of the fundamental frequency, because we know that the fundamental frequency for the first harmonic, that will be equals to V over 4L. So we can write here the F3 is equals to the 5 times of F1, and similarly we can show the fourth harmonic and for the fifth harmonic and so on. Similarly, for fourth harmonic, we will write here the F4 is equals to 7 times of F1, where F1 is equals to the V over 4L. That is the fundamental frequency. Okay students, in your lectures I have used this term corresponding to the overtone, not with the harmonics. Okay, it is a difference between this lecture and the lecture which is written in your notebook. For example, if we talk about the first harmonic, that is the minimum frequency of the sound waves by which we generate the first loud sound. Its frequency can be written as F0 is equals to V over 4L, as you have in your lectures, written lectures. And for the second harmonic, that is the first overtone, we have here F1 is equals to 3 times of V over 4L. So there is a difference between these video lectures and the written lectures. Okay, I have used in the written lectures the subscript of F with respect to the overtones, because it is a 0 overtone and it is the first overtone and the third overtone, fourth overtone. And in the video lectures I have used the subscript of F corresponding to the harmonics, that is the F1, F2, F3, F4. It is a difference. Okay students, please note it. Now thank you so much.